look at coterminal angles today. This is the rest of section 4.2. And what coterminal angles are is it's two angles that have the same initial and terminal sides, but possibly different rotations. These are going to be coterminal angles. Now, if we look up here at the examples we did in the last section, example B, angle alpha, 3 pi over 2, and example D, angle gamma, which was negative 5 pi over 2, they both have an initial side on the positive x-axis and a terminal side on the negative x-axis. So these angles are coterminal. We can see, however, though, that their measure is not the same. So even though they're defined with a different measurement, they land in the same spot. Coterminal, same terminal. That's what that means, okay? It makes sense that every angle then should have infinitely many coterminal angles because of the way we define angles in this class. You can do infinite rotations around a circle. So I can rotate any multiple of 2 pi. Remember, 2 pi is a whole circle. 2 pi times the radius is the arc length, but 2 pi is going to be the angle no matter what the radius is. And so no matter how many times I rotate, I could rotate to pi over 2 and then do a full rotation and land back at the exact same spot. We're just spinning around. And so you can have infinite definitions for the same location of that terminal side. So coterminal angles are going to be an angle of theta radians, ends up being coterminal with angles of theta plus 2 pi k, where k is an integer. This is not the first time we've seen this notation before. We saw this when we talked about periodic functions, and it makes sense. We said periodic functions are functions that have a repeating pattern over an interval that repeats over and over and over and over again. Well, if I am rotating around a circle, I have my starting point. I'm going to rotate and eventually get back to where I started. And if I keep rotating, I'm just going to repeat that rotation and then repeat that rotation over and over and over again. So I can start anywhere on the circle. If I have an angle like this, let's say that this is my angle theta, then I can also have an angle that rotates to this exact same spot, but maybe that rotated all the way around and then some, okay? That alpha is going to be theta plus 2 pi. I could also rotate around as many times as I wanted to. I could rotate 1, 2, 3, 4, all the way back to here. That angle is going to have like 6 extra pi added to it, but it lands in the exact same terminal side, okay? So this is the idea of coterminal angles. And again, this 2 pi k means any multiple of 2 pi. So I could add 2 pi, 4 pi, 6 pi. That would be if k is 0, k is 1, k is 2, no pi, 2 pi, 4 pi, and so on. Or it could be negative. K could be negative 2, which would mean I'm adding negative 4 pi, which would mean I'm doing the exact same thing, but I am rotating in the opposite direction. Like that, okay? So the way that we find coterminal angles is to add or subtract 2 pi. Now we are working with fractions here, so we're going to need common denominators, and you are going to want to work these out by hand because we don't want to put the pi's in our calculator, okay? So example 6 says, assume the following angles are in standard position. Find a positive angle less than 2 pi that is coterminal with each of the following. So our first example is 17 pi over 6. So the first thing I need to decide is that 2 pi over 1, I need to make that into 6. So I'm going to multiply by 6 over 6, which means 12 pi over 6 is what I want to add or subtract multiples of, okay? So if I start with 17 pi over 6, I need to get a number less than 2 pi. So that means less than 12 pi over 6. So I'm going to subtract 12 pi over 6, because again, this is really just 2 pi. And that will give me 5 pi over 6. So this is the angle that is coterminal with a 17 pi over 6 angle. They take a different amount of rotations, but they land at the same spot. Okay, now you can always check if you are less than 2 pi, take this number on top, divide it by the number on the bottom. 5 divided by 6 is going to be less than 1. So I know that that is less than 2 pi. If I had something like 13 over 6, 6 goes into 13 twice, that is too big. I need to subtract more than that. Okay, it always has to be a multiple of 2 pi though, not 1 pi. So be careful with that. Okay, let's look at B. So similarly, we need to get a common denominator. So 2 pi over 1, if I multiply by 12 over 12, I'm going to get 24 pi over 12. So that is my 2 pi. Now this one is negative. I need a positive angle that is less than 2 pi. So that means I want to add to it this time 24 pi over 12. Again, why? Because that's just 2 pi. 24 divided by 12 is 2. And so if I add, now I have 23 pi over 12. And then again, do a double check. 23 divided by 12 is going to be 1 and some extra. So it is less than 2, which means we're good. That is our coterminal angle. Okay? Pause your video and see if you can get the answers to C and D. I'll write them down, but you can go check the work on the PDF file if you want. C, we should get 3 pi over 5. And D, we should get 29 pi over 15. Okay? Again, these are worked out in the PDF file if you want to see the steps. Now, it might be necessary to add or subtract more than one multiple. Now, we're not working in degrees, so you can cross out the 360. We're only working in radians. So this says find a positive angle less than 2 pi that is coterminal with each of the following. So let's look at what's going to happen here. We can do this one at a time, or we can kind of think about it as we go. So again, 2 pi over 1, I need to make this into thirds. And you can do this in your head. You don't have to write this down, but I'm showing you for each of these. So 6 pi over 3 is going to be what we want. Notice if I just do 22 pi minus 6, I get 18 pi over 3. 18 divided by 3 is much bigger than 2. So that's not going to be enough. So you can keep subtracting, subtracting, subtracting one at a time until you find a number that works. Or we can start thinking about multiples of 2 pi. So 6 pi over 3 is 1. If I multiply that by 2, I get 12 pi over 3. So that might be enough. 22 minus 12 is going to be 10. 10 divided by 3, still bigger than 2. Add another 6 pi to that, 18 pi over 3. 22 minus 18 is 4. And 4 divided by 3 is less than 2. So that is the one that we want. So 22 pi over 3 minus 18 pi over 3 gives us 4 pi over 3. That is coterminal. Now, anything, if I had subtracted 6 pi over 3 or 12 pi over 3, those would also have been coterminal, but they wouldn't have satisfied the directions, which said a positive angle less than 2 pi. So we had to get to a number that was less than 6 pi over 3, which is what we got. So B is going to be very similar, but this time we're going to be adding because it's negative. So we already saw sixths on part A, 12 pi over 6. So again, if we kind of think this through, adding 12 pi over 6 is not going to be enough to get me positive. Negative 17 plus 12 is still going to be a negative. So add another 12 pi to that, and that would make 24 pi over 6. That one will be enough. So negative 17 pi over 6 plus 24 pi over 6, and that will give us 7 pi over 6. 7 divided by 6 is less than 2, so we are done. Okay, so just a little bit today to finish this up, talking about coterminal angles, and that should be good.